let's do one final problem here. And there's a problem, I think the last one on your homework is kind of similar to this, so this will help you with that. This one's a little more complicated than the last one on the homework, and in particular, it ends up at the end you need to find the roots of a cubic equation, and usually that's not very easy to do, and so we're going to use our calculator to find those roots. I think the one on your homework, you end up needing to find the roots of a quadratic equation, which is a lot easier. You can always use a quadratic formula or completing the square. So here's the idea. So this is the graph that we did earlier, where we found the slope of this tangent line here, and the work here that I did is actually down here. So I just copied the important stuff. So here's the line and here's the point. So I did the implicit differentiation solving for dy dx, and I got this. And then when I plug in the 0.42, I got a slope of 5/4. So now I'm going to find, what I want to do is, I can find the equation of the tangent line, but I don't need the equation of the tangent line. What I want to do is this. I want to see when the line that's normal, when is it going to, when is that going to, so the normal line would look like that. When is that line going to intersect this graph? So do you see that? Here's the graph. And in fact, the reason I chose this one is when I looked at this, it kind of almost looked like this was right across, and that maybe, you know, my picture isn't exactly accurate. I thought maybe this thing would actually cross at 2,4. So this is 4,2, this is 2,4. Maybe there's some sort of symmetry, and it was going to cross and go through that point. As it turns out, that is not the case. It's close to that, but it isn't quite that. So here's what we're going to do. So I don't need the equation of this line. What I need is the equation of this tangent line. Okay? So, I'm sorry. What I need is the equation of the normal line. So what I'm going to do is, we'll set up, my slope here is going to be the opposite reciprocal, so -4/5, and then I want it through the point 2,4. So we get like y is equal to -4/5 x plus b. So plug in 2 and 4. -4/5 times 4 plus b. So this would be 2 is equal to -16/5 plus b. So b is equal to 2 plus 16/5. So this would be like 10/5 plus 16/5, 26/5. Okay, and so that's my b. So my tangent line is, I'm sorry, the line that's normal is y is equal to -4/5 x plus 26/5. Okay, so whatever this normal line is here, okay, this isn't a perfect picture of that. It is a slope of a negative, it has a slope of a -4/5 x plus 26/5. And that's believable here. 26/5 is a little over 5, and this is actually, well, that's 6. So my line isn't exactly accurate here. So that's the line. So now what I want to do is I want to find where this line intersects the graph. Now, one nice thing is you can find, if you have two graphs, you can find where they intersect on here. But there's a problem, okay? So, well, let's see. Here's that's actually the graph that I'm going to be doing here. So you know what? Let me just put in two other things. So I could do like x squared and 2x minus 1. and then graph those. Oops, but let me do a different window. Excuse me. Let me just do a standard window. Okay. So there's my parabola, right? And then here is the line. Oh, you know what? I think that actually doesn't intersect the graph. So let me move that line up a little bit. We'll move that up to maybe 2x plus 1. So we'll graph my parabola, and then there's a line. And so one nice thing is you can find where two graphs intersect by hitting second calc and going to the intersect function. And so now what it wants is a first curve, so I want this curve, and then a second curve is this curve, so it wants the two curves. Okay, enter, because you could have more than two curves, and then the guess is just get close to where it is and hit enter, and then you can see that this point here that it intersects is like 2.414 whatever, and then y is 5.828. Okay, and so this can find where two graphs intersect. Now the problem is I can graph this line, but I'm not able to graph this. Okay, I cannot do that, and so I can't use this to find where the two lines intersect. That is a problem if I want to find where they intersect. So what I'm going to do is I'm going to think of this as solving a system of equations. I want to find where they intersect is an x and y ordered pair that solves these two equations. So one is y equals negative 4/5 x plus 26/5, and the other one is x cubed plus y cubed is equal to 9x y. Okay, so I want ordered pair that's going to satisfy both of these at the same time. That's where they intersect. Okay, well, this isn't like two lines where you can find where the two lines intersect. This is two graphs. So the way to do this is, fortunately, this graph I can solve for y. So I'm going to solve this one for y, and then I'm going to plug it into this. I'm going to do this is like the substitution method. So I plug this in. I need y to equal this, and then I'm going to plug this in for y into this equation. Okay? And so I get x cubed plus, this will be negative 4/5 x plus 26/5 cubed is equal to 9x, and then in for y, it's again negative 4/5 x plus 26/5. Okay, so I can plug it in, and now I got an equation all involving x, right? And so the roots of this equation will be any x value that solves this will be the x coordinate that where the two graphs intersect. Then I can plug the x coordinate into here and just calculate what the y coordinate will be, right? So that's how I can do it. Now this thing, if you look at this is this thing cubed, so you'd have to expand this out to get a cubic polynomial. Then you'd have to distribute that, and you'd get this quadratic, and then you'd have to bring everything to one side, combine all the like terms, and so basically this thing becomes a cubic polynomial is equal to 0. Okay? Now I don't want to expand all this out, because first of all, I don't normally, there actually is a cubic equation, like a quadratic equation. I don't know it by heart. I don't normally use it. people don't normally use it. But what we do is we put cubic polynomials in here, some cubic polynomial, and then we can find the zeros using the, if I hit second calc, there's that zero function, and it'll give us the roots of the polynomial. And notice a cubic polynomial can have up to 3 roots. Okay? And so let's see what happens here. So what I'm going to do is I'm going to just move everything to the other side, but I'm not going to simplify. And then this would be minus 9x. Okay, so what I did is I have all of this equal to 0, right? And now I'm going to graph the function y is equal to all of this. Now if I expanded that all out and combined like terms, I would get a cubic polynomial, and then I could find the roots on here, and those would be the x-coordinates where the graph intersects. Okay? And so basically that's what I had in here, if you look. So I'm... let me clear those out. So this here is, and you could get your calculator if you wanted to and plug this in, but there's the x cubed, and then there's all of that cubed minus 9x times all of that. So that's basically this polynomial, and you want to find where it equals 0, where this polynomial crosses the graph. So I'm going to just start by doing a standard window. And right here you can see that, okay, it's calculating it. You don't see much. Well, maybe it's not calculating it. It's not, because I got to select it. Okay, there we go. So now it's going to graph, and okay, all I see is this and that. So you don't see a whole lot of this graph. But one thing you see is that it does appear to go through the point 4. So if I hit second calc and hit value and put in 4, we see that it does equal 0 there. And so that is actually this point right here. So this is the line, this is the graph, and then that root, that's one of the places it intersects. Okay, this will be another place that it intersects, and I think it's right there, but if you look, this isn't quite 2. It's a little before 2. So this thing doesn't pass through the point. This is like the point 4-2. It's like right here. So it's not quite, I'm sorry, the point 2-4. Okay, so like I was saying earlier, it's not quite that. It's before that. And so we can find that root here by hitting second calc. And I'm going to go to the 0. And so now it wants me to go to the left side of the function. So I'm going to hit, there it is. I'm going to hit on the left side. And now I'm going to go to the right side and then go to the middle and hit enter. And then you see I get one of the zeros here, and it is like 1.7581. So 1 is 4, 1 is approximately 1.75813, something like that. And so this is the other point where it intersects. But now let's think about this. This is a cubic equation, so it's not just going up and down. Okay, it's not. This isn't like a parabola. This is a portion of the cubic equation, right? And so it has to. If it's like coming down here and going like this, it has to come back down and intersect this graph somewhere. It won't be over here. Because I can tell that it went down here and back up that way by the way it traced it out. So it's not going to go over here because the leading coefficient's positive. Okay, and so I can tell that it won't be that. And so let's see if we can find where it is. So you might want to do this. See if you can get a better picture of this cubic polynomial here. And let's see. I'm going to zoom out. You know what? My thing just froze up, unfortunately. And so that means I can't see the screen anymore. It freezes up here. Let me open it and see if it comes. Yes, it's frozen there, so I'm hoping you can see this. So you might want to pause and see if you can find a good picture of this parabola, or of this cubic equation, and see the other point where it intersects. And it's going to be over here quite a bit. Okay, and then when you unpause, I'm gonna just keep working on it here. You can see what I come up with. So. Okay, so now I'm going to go searching for that. So if I zoom out, I'll start by zooming out. We're going to see what happens. Okay, it's not a terribly good picture, and you can see part of the problem here. This thing must be, it's going to, I don't want it to be all squished in here, but this thing clearly is going to go up and back down, but it looks like it's happening further out over here. So you can play around and try to get a better picture, but I don't need much more over here. So what I'm going to do is I'm going to select a window, and so my maximum, let me just go to 5, or maybe I'll go a little more than that, 6 or something. And then the minimum, negative 38 isn't enough, right? So I'm going to go to maybe negative 75 or something to 6. And then the y min, I don't need to go too far below the axis, I don't think. So I'm going to go to negative 10. But I do think this is going up higher, it seems to me, and so maybe I'll go up to 100 or something. And let's see what this does. Okay, so there it's there, but you can tell that this goes way up and down, so this is still not like the greatest picture. So I think I need to go higher, don't I, on here. So maybe I'll do 200, and then maybe negative 50, and then these, maybe I can go to 10 here. Stretch that out a little bit. Okay, you still don't get a very good fit. Now let me show you the best kept secret here. If I hit zoom, if I hit zoom and I go down, it's number 10 on this list, zoom fit. It will give you a picture, and it might be a good place to start. So let's do that. It's given me this. There, look at that. It goes up. It's very weird. Okay, so let's see what our window is there. Doesn't seem to need all of that necessarily. So it looks like it's going up to like 10,000, right? Or this thing doesn't need to be 10,000, I don't think. So let's do negative 100. And that negative 75. Oh, it kept that window, didn't it? So let me do negative 50. So let's graph there. It's going up. And that's still, there's not a lot there, so let's put some more on the bottom. So there you're starting to get a pretty good picture. So let me finally put some more on the bottom here. Oh, it's because I started at 100. I was going to do a negative 100. There we go. But I could even do a little more there. So finally, let's just do negative 500. That'll be our last one. And that's plenty good. And you can see that it's intersecting way over here. And that's the 1.75 we just found. That's the 4. And then it goes back up. So now let's find that root. That's what we want to do. So, and I'm going to do the second calc, go to 0, and then I need to bring this over here. I need a left bound, so I need to go under, and then over, and then in the middle. And then there it finds this, a negative 40.97125. Now let's, I'm going to zoom out here, or is that zoom in? And I think I'm zooming, hopefully I'm zooming out. And so what I want to do is, these are the 3 points, x points, where it intersects the graph. So one is 4, 2. Another one is 1.75813, and then I'm going to get my calculator and plug that in. So it'll be negative 4/5 times 1.75813 plus 26/5, and I get like 3.793496, something like that. And then the other one is this, the x coordinate is this, and let's find the y coordinate here. So it'll be like 40.97125, and it's like 27, negative 27.577, something like that. So these are the other ordered pairs. Okay, so I really hope I'm zooming out there by clicking on that. And so let's see, this one is the other. This is the 1.75, right? 1.753 point whatever. It's like right here. And that's the one that's perpendicular. So where's the other one? And it is negative 40. So I'd have to go, this is like negative 6. So negative 40 is way over here. Negative 27 way over there. So somewhere out in the upper left-hand quadrant, so in this quadrant 2, way out there, this line and that graph are going to intersect each other again, and we found out where by solving this system of equations. Okay, so there you go, and that's using some of the technology there, but also realizing we need to know a little bit about cubic polynomials, roots, all that, so that we get a good window and we find what it is that we're looking for. Okay, and in particular, this is a neat example because you might never have thought about it intersecting at a third spot way out. So, okay, so after this implicit differentiation, we're going to use that technique to solve related rate problems. And so these are kind of fun, interesting application problems using the implicit differentiation.